Hello everyone, I'm Youssef. I'm PhD student with BRGM and the University of Orléans. And I'm here today to talk about the first result of my PhD. I will present deep learning model to classify building user type using building footprint from BD TOPO and aerial images. So here is the roadmap of the talk. I will start by the scientific context and objective of my PhD. Second, data sources. Three, the proposed pipeline. Four, the model and results. And I finish by conclusion. The context of my project is the vulnerability assessment to natural hazards. So the natural hazards are natural phenomena that could be, for example, Schindler's wave phenomenon, flooding, earthquake, etc. So the natural hazard is determined by the nature and the vulnerability of the exposed elements. So the exposed element are all the elements that could be impacted or damaged by the natural hazard. For example, if we take a earthquake, so the earthquake could damage buildings. So the buildings are our exposed elements. And the objective of my PhD is the vulnerability assessment. So why we want to do that? Because if we can measure the resistance of each exposed elements or each assets, so we can reduce it. And if we reduce the vulnerability, so we can reduce the risk, because the risk is an intersection between the natural hazard and the exposed element. So the natural hazard is a natural phenomenon. So if it is out of our control, so if we reduce the vulnerability, we can reduce the risk. So here is an example in the Schindler's wave phenomenon. So this natural hazard, it's caused by clay soil. So when we have clay soil and we have heat waves, so the soil can the soil contracts, and after when we have a rainy period, so the soil expands. So due to this movement, a building can have damage in and cracks in the walls. So if we take two buildings, A and B, they are constructed on the same soil and they are on the same meteorological condition. We can see that the construction B have damage in the damages and the cracks in the walls, but construction A is still intact. We understand that there is some characteristics that make the construction A less vulnerable to construction. So these characteristics are called vulnerability factors, and we do work on the literature to extract all the vulnerability factors on buildings to the natural hazard Schindler's wave phenomenon. And from this, we understand that the most exposed elements in our natural hazard Schindler's wave phenomenon are the building or the house, the residential building. So let's see this map, which illustrates the territorial exposure of Schindler's wave phenomenon. So as you can see, the issue is considerable. In France, 10 million single-family houses are highly exposed. 3 out of 4 municipalities have more than 15% of house exposed, and this natural hazard is the second leading cause of insurance after floods. Some example of damage that can of building damage, for example, cracks along the walls and distortion in the openings. So the first step of my PhD is to identify first all the residential building in the region Centre-Val de Loire and in France. So we did to automatically identify the building. So we understand that it's not a straightforward task. It has some challenges. So first is the scalability. So mapping all the building in France, it's really time consuming, so we can't do it manually. Second is the data quality. So we have some data on open data sets like OSM, but it's still not still have many problems like data quality, missing information, outdated information. Three is the attribute gap. So we need some attributes like the usage type of the building, that this information you can find it in all the databases. And four is the resolution limits. So we have also some global data sets, but we don't have a really good global data set at the scale of the building. So we did an investigation on the data sources, and we will work on data sources from BGM. So the first one is the BD TOPO, which is it is a national database and an open data set that contains extensive information and an aggregation from multiple data sets such as the cadastral records, the house tax data, the OSM, and many other sources. Second one is the BDR2. So we have, we will use the IRL images at a very high spatial resolution. And the last one, sorry, and the last one is the Coziites and cover produced at very high spatial resolution. So here is an example. So from the IRL images, we have here, we can extract the IRL image. From BD TOPO, we have the building footprint that correspond to this area. And here we can extract for each building its footprint, so the red polygon. And we have an information in BD TOPO, which is the usage. So we can know for each polygon its usage. But the problem in the two first department we studied, we have more than 32% of the building with an unknown usage type. So we know that we have a polygon, we have a building, but we don't know the usage type of this building. So in the case of vulnerability assessment, we can't ignore this unknown type, because this unknown building could have some residential building which are really essential and important in our study. So we decide to reclassify this unknown building using the BD TOPO and the IRL images, and using deep learning. So here is the pipeline. So first of all, with from BD TOPO and the land cover, we did some pre-processing steps to clean the BD TOPO, because we have some problem with some polygons. Some polygons are overlapping with a non-built up area, and so we reduce the number of the missing polygon problem. Second, so once we have here the BD TOPO cleaned, we crop from the IRL images. We do a crop, and we create a data set here with the building, and for each building we know its usage type. So once we create the data set, we will use some pre-trained model and fine-tune them to reclassify the unknown building. So we tested some pre-trained model on different data sets. So the first one is Orosat, which is a data set that contains 10 classes and Sentinel-2 images. Second one is IRL image data set with 30 classes and 10,000 image and ImageNet, 1.2 million images. So once we pre-train the model, we fine-tune the model on our building usage data set. And here is some of the fine-tuning parameter. And here we obtained the best performing model is ResNet 50, which is pre-trained on ImageNet. And as you can see here, the ResNet pre-trained on IRL image dataset have closer results. So that's show that when we also select a dataset from model pre-trained on dataset that have a close task to our downstream task, we can have really close result even with a small dataset, because AIG contains 10,000 images. So the overall accuracy is 75%, but we have some errors that occur between two classes, the industrial and the commercial building, and we shall show some example of the commercial building that the model predict as industrial here. So on the left side and on the right side, industrial building that the model predict as commercial. And as you can see, the building, the examples are really close. So that's why the model made this type of error. And it is the same thing between the residential building and the annex. So the model here predicts some residential building as annex, and here the model predicts some annex as a residential building. And here also some examples are really close. Another experiment. So when we create here the data set, here when we create our data set, we use a buffer size, for example, around the building to catch the environment. So when we create this buffer, we use the two buffer, two sizes, 5 meter and 15 meter, and we want to study the effect of the buffer size on the prediction. So if we have more information around the building, it could help or not the model. So for commercial service and industrial building, the building. So for commercial and industrial, we have better results. So we think that it could be related to the environment that it's always the same around this type of buildings. So we have parking lots, we have big roads. So that's why with bigger buffer size and with bigger information, we have better prediction. So here is some example of the prediction and the reclassification of the unknown building. And here we calculate, so we reclassify all the unknown building and we calculate the proportion of each class. So in our unknown building, we have 25% of them are residential. So that's highlight the importance of our method. So if we would ignore at the beginning or the unknown building, we miss many residential buildings. So to sum up, this method demonstrates the ability to fill the BD TOPO, and but in some cases, the error images alone cannot determine a building function. And for the perspective, we will explore data fusion architecture to integrate additional modalities, and we'll analyze the model errors and develop method to better handle uncertainty. So it's not the final version, but I have the article accepted in the conference ACML, so I can give you the link to the article. Thank you for your attention.
Thank you very much and congratulations.
Thank you.
There are some questions. We have time for 1 or 2 questions.
Have you discussed with people working on BD TOPO? Because I think they could tell you probably why they are missing data, and will you give you ideas on what sources of data you could use to remove the ambiguity?
Yes, so actually, you may be interested in the OCSGE, which is another product of IGN, for which we have a layer of usage for any building, and it's much more complete than BD TOPO.
So in BRGM, we have many people that are working with the IGN, and I think BD TOPO, they extract the information from cadastral records, from all the data. So I think that
Yes.
if we have missing information in the BD TOPO, that means that this information is missing in one of the other data sets.
Yeah, but also because we have another product for which we want the usage in particular, which is the OCSGE,
Okay, yes.
for which COSIA is an intermediate tool. So you may be interested to use it either for reference or.
Okay, I will check this. So OSGE, because I saw that the land cover map is produced also with this tool, right?
No, the land cover map
Yes,
is
that's
used as a
produced.
tool to produce OCSGE. But for the usage, it requires like manual edition.
Yes.
And it's
Okay. I will. Thank you.
Any other questions?
Short.
Short. Yes. Do you have sorry, I missed a bit of your presentation. Do you have a map of where the buildings are damaged are localized or?
I have this information from the insurance company because it's a potential project. But the problem is we can't have all the buildings because the insurance company have her clients, so we can't know if one building is damaged because we have the information or because this building is not the client thing. But we have some example.